The product rule tells us how to find the derivative of a product of two functions. So if f of x and g of x are two functions that are differentiable at x, then d dx of f of x times g of x equals f prime of x times g of x plus f of x times g prime of x. To prove this rule, we will use the definition of the derivative. And the definition is f prime of x, which we can write as d dx of f of x, equals the limit of f of x plus h minus f of x over h as h approaches 0. So we will start with d dx of f of x times g of x. And now we will apply the definition. So this equals to the limit. And if here we had f of x, now in the numerator we have f of x plus h. In the product rule, we have a product of two functions, and each x has to be replaced with x plus h. So then we will have f of x plus h times g of x plus h minus f of x times g of x over h as h approaches 0. Now, to continue with the proof, in the numerator we will add and subtract the same quantity, and that is f of x times g of x plus h. So here we have the limit, and now we will start a fraction bar, and in the numerator we will bring down f of x plus h times g of x plus h, and now first we will subtract the quantity f of x times g of x plus h, then we will add the same quantity. Then we will bring down minus f of x times g of x all over h as h approaches 0. In the next step, we will split this fraction into two fractions, where the first will have this numerator and the second will have this numerator. So then here we have the limit, and we will create two fractions. And in the first one we will write f of x plus h times g of x plus h minus f of x times g of x plus h all over h. And in the second fraction we will have f of x times g of x plus h minus f of x times g of x all over h. Next, we will take the limit of each of these fractions. So here we took the limit of the first fraction, then the limit of the second fraction. Now, in the first fraction, in the numerator we have a difference with a common factor g of x plus h. So we will take g of x plus h and we will factor it out to the right. Then we will have the limit of f of x plus h minus f of x over h multiplied by g of x plus h. So we just factored out g of x plus h. In the numerator of the second fraction, we also have a difference with a common factor f of x. Then we will take f of x and we will factor it out to the left. So we will have the limit of f of x times g of x plus h minus g of x over h as h approaches 0. Now, when we have the limit of a product, we are allowed to take the limit of each of these factors. So we can write all this as the limit of f of x plus h minus f of x over h as h approaches 0 multiplied by the limit of g of x plus h as h approaches 0 plus the limit of f of x as x approaches 0 times the limit of g of x plus h minus g of x over h as h approaches 0. And now we will evaluate each of these individual limits. This limit, according to the definition of the derivative, is f prime of x. In the next one, if we replace h with 0, we will have g of x. The next one does not have h, so it will stay f of x. And the last one, it is the definition of the derivative, and it will be g prime of x. So then, now we will write that d dx of f of x times g of x equals f prime of x times g of x plus f of x times g prime of x. And this is the proof of the product rule. Thank you for watching.